So previously we looked at two vector operations that produce a vector. We look at vector addition, and we also look at multiplying a vector by a scalar quantity. Here in this section we're going to look at the vector operation that produces a scalar quantity. And this vector operation is known as the dot product. The dot product of two vectors u and v is defined as u times v is equal to u1 times v1 plus u2 times v2. Note that this rule is reversible, so u times v is the same thing as v times u. Also, we know that 0 times a vector is always going to be 0. For vectors, we can also use a distributive property. So u times v would be equal to u times v, the dot product, and this will be equal to u, the dot product of w. So dot product multiplied by a scalar quantity is equal to that scalar quantity times one of the vector, and then find the dot product times the second vector. Or we could have the first vector times the second vector times that scalar quantity. Now let's get a couple of examples that demonstrate the dot product. So here we're finding a dot product of u and v. We're told that u is equal to 6 and 10. So this is our u1, u2. And we're told that v is equal to -2 and 3. So this is our v1 and v2. We know the dot product of u and v. So we have u times v is equal to u1 v1 plus u2 v2. So this will be 6 times -2, or u1 times v1 plus u2, which is 10 times v2, which is 3. So this is -12 plus 30, which gives us 18. So the dot product of u times v here will give us 18, which is a scalar quantity. Now we're told here in this example that u is equal to 3i plus 4j, and that v is equal to 7i minus 2j. So once again, this is our u1, u2, this is our v1, v2. It's just written in as a linear combination of our unit vectors, but still our u1, u2, still our v1, v2. So we know u times v, or the dot product of u and v, is equal to u1 times v1, so this is going to be 3 times 7. This is going to be u2 times v2, so it's going to be 4 times -2. So this becomes 21 minus 8, which is equal to 13. Now, one of the many applications of the dot product of a vector is to find its magnitude. We will demonstrate that using this example. Here we're told that u is equal to 12i minus 16j. The formula we use to find that is that the magnitude squared is equal to the dot product of that vector. So to find the magnitude squared, we take the dot product of the vector itself. So this will be 12 times 12 plus -16 times -16. So here we have 144 plus 256. So which gives us 400. Now this is the magnitude being squared. So to find the magnitude of the vector, we can now take the square root of both sides. So the magnitude is equal to the square root of 400, which is 20 units. Another application of the dot product of a vector is to find the angle between those two vectors. Here we're defining that the angle between two vectors as theta. So theta is the angle between two non-zero vectors u and v, and we know that cosine of theta is equal to the dot product u times v divided by the magnitude of u times the magnitude of v. From this we can actually find theta. We know that theta will be the arc cosine or the cosine inverse of the dot product of u times v over the magnitude of u times the magnitude of v. So here we're being asked to find the angle between the two vectors u and vector v. We're told that the component form of u is 3, 2, and the component's form of vector v is 4, 0. We know to find the angle theta, we can use this formula. Cosine of theta is equal to the dot product of the two vectors u and v divided by the product of their magnitude. So if you find the dot product first of u times v, this will be 3 times 4, which is 12, plus 2 times 0. So this simplifies to give us 12. To find the magnitude of u, this would be 3 squared plus 2 squared, so that's 9 plus 4, which is 13, and the square root of 13. Here this would be 4 squared plus 0 squared, which is the square root of 16, which just gives us back 4. If we simplify the 4 and the 12, we get 3 over radical 13. So cosine of theta is equal to 3 over radical 13. Now to find theta, we can take the arc cosine of this. So theta is equal to the arc cosine of 3 over radical 13, which gives us 33.69 degrees approximately. Now in the second part, we're told that u is equal to the cosine of pi over 3i plus sine of pi over 3j. We're also told that for vector v, it's equal to the cosine of 3 pi over 4i plus the sine of 3 pi over 4j. Now we can do the same thing we did here by taking the dot product of u times v and then finding the magnitude of u and the magnitude of v and dividing it by that. However, because we know the direction of vector u, which is pi over 3, and we know the direction of vector v, 3 pi over 4, we can easily find theta, the angle between the two vectors, by subtracting the two angles. So if we know that one vector is going in this direction and one vector is going in that direction, then the angle between is just the difference of the two angles. So here, if we take 3 pi over 4 minus pi over 3, we find that the angle theta between the two vectors is just 5 pi over 12. In this example, we're being asked to find the dot product of u times v given the magnitude of both u and v and the angle theta between the two vectors. So the magnitude is equal of u is equal to 4 and the magnitude of v is equal to 12. The angle theta between the two vectors u and v is equal to pi over 3. We know from our formula that cosine of the angle between the two vectors theta is equal to the dot product divided by the magnitude of u times the magnitude of v. If we rearrange this formula by multiplying both sides by the magnitude of u and the magnitude of v, we have u times v is equal to the magnitude of u times the magnitude of v times cosine theta. So here we have the dot product of u times v. So now all we need to do is substitute for the magnitude of u, which is 4, times the magnitude of v, which is 12, times the cosine of theta, which is pi over 3. So this is 4 times 12, which is 48. The cosine of pi over 3 is 1/2, so it's 48 times 1/2, which is 24. So the dot product of u times v is 24. Previously we were just talking about the angles between vectors. Sometimes the angle between two vectors is 90 degrees and we refer to that as being perpendicular. Another name that we use for a perpendicular vectors are orthogonal. So we know that two vectors are perpendicular if their dot product is equal to 0. So if we find a dot product of a vector u and v and it's equal to 0, then we know that the vectors are at right angle to each other, which means they're perpendicular or orthogonal. To find out if they're parallel, we can determine if one vector is a scalar multiple of the next. So if we're to multiply v by 2 and we get u, then we know that these two vectors are parallel. Now we're going to look at a couple of examples that determine whether or not two vectors are parallel or perpendicular. So in this example, we're being asked to determine whether or not the two vectors u and v are parallel, orthogonal, which means perpendicular, or neither. So in our first part, we're given that vector u is equal to negative 1230, and that vector v in its component form is 1/2 and negative 5/4. Now to determine first of all if they're parallel, we said parallel vectors are a scalar multiple of the next one, so we could possibly divide both of these quantities. So if we divide negative 12 by 1/2, this becomes a negative 24. And if we divide 30 by negative 5/4, this also gives us negative 24. So we can see that vector u is negative 24 times vector v. So u is equal to negative 24 times vector v. So u is actually a multiple of v. So because u is a multiple of v, then we can say these are parallel. On this example, we're going to try and figure out whether or not they're parallel or perpendicular. If we do the same thing, we have 2 over negative 1, which is negative 2, and this is negative 2 over negative 2, which is a positive 2. So these are different, so we know they're not parallel. For them to be parallel, these would have to be the same quantity. If we take the dot product, we have u times v, so this is 2 times negative 1, which is negative 2, plus negative 2 times negative 1, which is a positive 2, so this is equal to 0. Since our dot product u times v is equal to 0, we know then that they're orthogonal or perpendicular. And if they were neither perpendicular or parallel and perpendicular, we would say they were neither.